Assalamu alaikum. So previously we covered about the metaphors and analogies with respect to the mental models and representations and your interface. Now let's move forward. So let's revisit a couple of design principles which we have already discussed in our last video lecture. So in our lecture on design principles, we touch on a number of principles that are relevant to these ideas of mental models, representations, and metaphors. First, the idea that people reason by analogy to pass interfaces or by metaphors to the real world is one of the reasons that the principle of consistency is so important, which is of course was proposed by Don Norman, Jacob Nielsen, and Constantine and Lockwood. We want to be consistent with the analogies and metaphors that people use to make sense of our interfaces, like this. Second, when we say that an interface should teach the user how the system works, we are echoing the idea of affordances. The way the system looks should tell the user how it's used. Just by observing the system, the user should be learning how to interact with it. The third, representations are important because they map the interface to the task at hand, like the mapping attribute. A good representation is one that users can use to predict the outcomes of certain actions. In other words, a good representation lets user predict the mapping between their actions in the interface and outcomes in the real world. Now, in designing interfaces, we want to leverage analogies to the real world and principles from past interfaces whenever possible to help the user learn the new interface as quickly as they can. But there is a challenge here. Why we are designing technology if we are not providing users anything new? Now, if you remember, we have discussed about this thermostat thing in our last lectures, and I told you that what are the characteristics of these two thermostats. This particular Nest one, this thermostat is actually based on speech recognition, and it has a sensing capability to adjust the temperature on its own. So it's one thing to take the technology they are already using and make it more usable. But generally, we also want to enable people to do things they have never done before. That means that there are no analogies, no expectations, no prior experiences for them to leverage. How do you tell someone that's used to control their own thermostat that they don't need to do any more? So while we need to leverage analogy and prior experience wherever possible, we also need to be aware that eventually we are going to do something interesting and they are going to break down. Eventually, we are going to have to teach the user to use the unique elements of our interface. Now, all the learning things to make the users learn, it depends on the learning curves. So every interface requires the user to do some learning to understand how to use it. Very often we visualize this as a learning curve. And the learning curve is mostly represented by the expertise and experience. Generally, as the user gains more experience, they also gain more expertise, like this. But remember that our assumption is when the user starts, the user does not have expertise and the user does not have experience. So here our user starts with no experience at all. Our goal is for them to end with an expertise above this line of proficiency. However, the shape and steepness of this curve can vary. Ideally, we want a learning curve that grows quickly with relatively little experience. This is actually what we call a steep learning curve. Although usually when you hear steep learning curve, it means the exact opposite. Technically, Steep is good because steep means we are increasing very quickly with relatively little experience. People often use steep to mean the opposite, and that's because steep calls to mind connotations of a high difficulty level, like climbing a steep mountain. So steep is actually a poor representation of this concept. So instead, let us call this a rapid learning curve, which means that expertise grew very quickly with relatively little experience. Rapid calls to mind probably the proper connotations that a rapid learning curve is rapid learning, which is probably something we want. Now, interfaces that are more difficult to use would have slower learning curves. Here, the user needs a lot more experience to reach the same level of proficiency. So, how do we help our user reach proficiency faster? For one, if we are consistent with existing conventions and use analogies that users understand, we can actually start them off with effectively some initial expertise like this. As you can recall, previously we assumed that the expertise of the user was at this point. Now, if we use the consistencies, we can assume that the users have some initial knowledge or some initial expertise while using the other interfaces. So for example, when you download a smartphone app, you know that three horizontal lines that often appear in the top right likely indicate a menu. So that's a consistent convention used across multiple apps. So using it means that when users open your app, they already have some expertise. From there, we want to make the ascension as rapid as possible. One way we can do that is by using representations and affordances that help the user immediately understand how to use the interface. So good design in part about helping users achieve proficiency as quickly as possible. Either through starting them off with some initial expertise or helping them grow in their expertise with as little experience as possible. So let's discuss about some user errors, which we name it as slips and mistakes. So as we design interfaces, we will no doubt encounter instances where the user makes mistakes. Sometimes this might be because our users are stressed or distracted, but other times it might be because our users fundamentally don't use our interfaces or even don't understand their own goals. So as designers, though we know there's really no such thing as user error, any user error is a failure of the interface to properly guide the user to the right action. In designing interfaces, there are two kinds of user error that we are interested in avoiding. The first are called slips. Slips occur when the user has the right mental model, but does the wrong thing anyway. Take this box for example. Prompting a user closing a program on whether they'd like to save their work, in all likelihood, user knows exactly what they want to do, and typically it's going to be to actually save their work. If you ask them to explain what they should do, they would say, click yes. But imagine if the order of these buttons was flipped so that the no was on the left and the yes was on the right. A user might click on the left just because they are used to seeing yes on the left, even though they know they really want to click yes. Or imagine that no is selected by default, so that if a user just presses enter when this dialog comes up, it automatically says no. In that case also, they knew that they wanted to save their work. But what they didn't match the goal, what they did didn't match the goal they wanted to accomplish. A mistake, on the other hand, happens when the user has the wrong mental model and does the wrong thing as a result. Take this prompt for example. The users asked if they want to revert to the original file. That's really just a backward way of asking whether they want to save, but this is foreign terminology to many users. Their mental model of what saving is doesn't tell him what to do in this instant. What's more, they don't actually have a choice here. Without a cancel button, they are forced to choose, knowing one option could mean losing their changes. Here the problem is a mismatch between their internal model and the way the system is working, or at least the way it describes itself. So slip occurs when the user knows the right thing to do but does the wrong thing instead. But a mistake occurs when the user doesn't even know the right thing to do. So let's discuss some types of slips. Don Norman further divides these slips into two different categories: action-based and memory lapse. He describes action-based slips and memory-less slips, such as action-based slips are places where the user performs the wrong action, or performs a right action on the wrong object, even though they knew the correct action. They might click the wrong button or right-click when they should left-click. A memory lapse slip occurs when the user forgets something they knew to do. For example, they might forget to start a timer on a microwave. They knew what to do, they just forgot about it. So action-based slips are doing the wrong thing, and memory-based slips are forgetting to do the right thing. Now in this dialog, clicking no when you mean to click yes would be an example of action-based slip. The very existence of this dialog is meant to prevent a memory-lapse slip, where a user would forget to save their work before closing. Now similarly, there are different types of mistakes. Don Norman also divides them in multiple categories, in this case 3 categories. The rule-based mistakes occur where the user correctly assesses the state of the world, but makes the wrong decision based on it. Knowledge-based mistakes occur where the user incorrectly assesses the state of the world in the first place. Memory lapse mistakes are similar to memory lapse slips, but this focuses on forgetting to fully execute a plan, not just forgetting to do something in the first place. If the user clicks the wrong button in this dialog, it could be due to multiple different kinds of mistakes. Maybe they correctly knew they wanted to save their changes, but they didn't realize that clicking no is actually what would save. That would be a rule-based mistake. They knew they wanted to save, but they made the wrong decision based on that knowledge. Or perhaps they didn't realize they wanted to save in the first place. Maybe they didn't think they made any changes, when in actuality they did. That would be a knowledge-based mistake. They applied the right rule based on their knowledge, but their knowledge was inaccurate. If they were to shut down their computer and never come back and answer this dialog in the first place, that might be considered a memory lapse mistake. They didn't fully execute the plan of closing down the application. So in our designs, we want to do everything we can to prevent all these different kinds of errors. We want to help prevent routine errors by leveraging consistent practices like designing dialogues the way users are used to. We also want to let our interface offload some of the demands on working memory from the user to the computer to avoid memory lapse errors. And we want to leverage good representations to help users develop the right mental models to minimize these rule-based and knowledge-based errors. And while errors are inevitable, we should make sure to leverage the tolerance principle to make sure the repercussions can never be too bad. So let's take a quiz. A user accidentally sends a text message to the wrong person, and I perfectly know that we have been in this situation one way or another. So the question is this a slip or a mistake? Now you can think about it and just try to think of an answer between these two. But in my opinion, I would argue this is a slip. The user knows who he/she wants to message, but the phone's behavior tricks him/her into sending things to the wrong people. What's more, this might be either an action-based slip or memory lapse slip. Maybe the user is tapping the wrong person, or maybe the user is forgetting to check who he/she is messaging. So take a minute and brainstorm a design for this that can prevent this from happening in the future without ever complicating the interaction too much. Now take a moment, and I would give you 30 seconds to think about it, and just start a thread or just comment, or you can left me a comment in Google Classroom, and let me know that what do you think of, or can you come up with an interface which could fit this bill, like not complicating the interaction too much while uh, making the user aware that who he or she is trying to message. So I hope you have thought of something, or if you haven't, just think of something if it's other than my opinion. So I would argue that the best way to do this is simply to show more pervasive reminders of who the user is currently texting. We can show the recipient's picture on the send button, for example. That way, the interaction is no more complex, but the user also has to directly acknowledge who is he or she sending messaging to send a message. And in this way, he or she will be intimated that, okay, I am sending the message to this user. If I want to send message to this particular user, it's okay. Otherwise, he or she can correct that particular slip or that particular error to happen in the first place. Now, another important aspect is the learned helplessness. The feedback cycle in HCI is reliant on a relationship between the user's input and the interface's output. The idea of this cycle is that the user learns from the output what they should have input. If they do something that causes an error, they receive feedback on how to avoid that next time. If they do something correctly, then they see that their goal was accomplished. That's the principle of feedback. But what happens when there is no discernible interaction between the input and the output? What happens when there is break in this cycle? What happens when the user acts in the system over and over and over again but never receives any output that actually helps? What if they never even receive output that indicates that the computer is understanding them or receiving input from them? That's when something called learned helplessness sets in. The human working with the interface learns that they are helpless to actually use the system. They learn that there is no mapping between their input and the output they receive. As a result, they believe that there is just nothing that they can do to accomplish their goals. And no one wants to feel that way. No one wants to feel like no matter what they do, they are destined to fail. No one wants to feel like they are failing at something that everyone else seems to do very easily. So, it's very natural for people to develop this resistance to even try and to learn about this interface. Now, learned helplessness is very similar to the mental models because it is also a topic related as much to education as it is to HCI. If you ever spent any time in teaching role, you very likely encountered students that are very resistant to being taught. You can relate to the current crisis and situation perfectly because it reflects that. And the reason I assume is they have learned that no matter what they do, they never succeed. They have learned to be helpless based on their past experiences or based on their mental models. In all likelihood, there have actually been situations where you have been the one learning that you are helpless. In fact, if you are a parent or if you have a very young sibling, I can almost guarantee you have been in that situation. There are times when your young sibling child was crying and inconsolable and you had no clue why. This often happens to married men as well, in some situations while they fights with their wives. They actually don't know why their fight is going on. Nothing you did helped, and you learned that you were helpless to figure out what your child wanted. So if you are a parent or a guardian and you are dealing with learned helplessness as an interface designer, just imagine that you are the user and the interface is your screaming child. What feedback would you need from your child to figure out how can you help them? And how can you build that kind of feedback into your interface? Now, let's do an exercise. Type and repeat the following. I am not my user. Now, if you are really serious about being an interface designer, write it on a post-it note and stick it to your monitor. If you wear glasses, write it on the inside of the lens. Record yourself saying it on your phone and set that as your ringtone. Do whatever you have to do to remember this rule. I am not my user. So in order for us to really sympathize with users suffering from the effects of learned helplessness and expert blind spot, it's important for us to understand what it's like to be in that position. We have all experienced these things at some point in life, although at the time we might not have understood what was happening. So take a minute and reflect on a time when you experienced learned helplessness and the effects of expert blind spot from someone trying to teach you something. It might have been in a class, it might be learning a new skill, or it might be doing something that everyone else seems to do just fine day to day, but for whatever reason you have always struggled with. So, according to me, many men relating to cooking completely feel helpless. Sometimes working men accidentally make toast but while eating they realize that it isn't good enough. Many people try to cook from recipes. For instance, I once tried to make a custard by following a recipe, following the guidelines. But once it was made, I realized that it was not viscous as I was expecting it to be, and the sugar was short. I realized that following the recipe was not easy because many recipes are written for experts. For instance, the recipe here, it calls for a medium saucepan. Like, what is the size of a medium saucepan? How would I know? I have no idea. This recipe calls for 1 egg beaten with a splash of water. A splash, like a splash when you overfill a water bottle, or a splash when your sibling soaks you at the pool. It also mentions pulse to combine. Cook until the edges are golden brown. Now what's this golden brown? Give me a color code and I'll compare it. But otherwise, I don't know where on the electromagnetic or visible color spectrum from golden to brown this golden brown lies. This makes me scratch my head. Now these are the examples of places where the directions are given in a way that assumes I already have some expertise that I really don't have. So that's why it is important to learn this rule that I am not my user. So let's conclude this week's video lecture by summarizing it. So in this week lectures, we talked about mental models. We discussed how good representations can help users achieve strong models. We did discuss how issues with interfaces can lead to two different kinds of user error slips and mistakes. We also discussed what mental models are and how the user uses them to make the sense of a system. We then discussed learned helplessness, which can come from giving poor feedback on user errors. Finally, we discussed expert blind spot and the importance of understanding that you are not your own user. So go through these videos, and if you have any question, if you have any problem in understanding the concept or a specific concept, you can just ask me questions on the Google Classroom, or you can discuss it with me in our live session by mentioning the slide number. It will be helpful for me to make you understand with different examples, and it will also save our time while the live session is quite limited. Also, I have asked you to complete an assignment with respect to your chosen application or chosen mini project regarding HCI. So I hope that you will submit your assignment by the end of this week. Thank you. We'll meet next week. Till then, goodbye.